Anyway, we just got a cross-reference here. Fossilized Footprints, a Dinosaur Dilemma. I gave you the link. You can go to D for Dinosaur Footprints under the index here, D, for dinosaur. And scroll on down and go online. I'm not online here. And take a look at those footprints. Photos from the Paluxy River. And you'll get the pictures. They're amazing. I was actually in the museum there, and I saw one of the footprints cut open. They cut the big, huge section of the riverbed there that's fossilized. And they cut through the toes to make sure that they were not forged toes. And they are actual real toes of dinosaurs and real toes of humans in those toes of the dinosaurs, so they coexisted together. Amazing. Anyway, let's go back. Cool, dinosaur tracks. How can today's slow and gradual geologic processes over millions of years explain the preservation of delicate impressions in mud before they are washed away? Does the flood provide a better explanation? Thousands of dinosaur footprints have been found in the geologic record, often in long trackways of successive left and right footprints. With the help of these clues, paleontologists have deciphered many details about the behavior of these fascinating creatures. Who has a dilemma? Dinosaur footprints create an apparent dilemma for creationists. How can they ever be made and fossilized during the flood? After all, with the flood waters covering the entire Earth, the dinosaurs would have nowhere to walk. Even if they did, the churning waters would erode away any footprints left behind. Secular geologists and skeptics often raise this question and are sometimes scathing in their mockery. Biblical geologists, on the other hand, say it is the conventional geologists who, in fact, face a dilemma. If geologic change takes place slowly, surely footprints made in the mud would be obliterated by wind and rain long before the prints were covered by new sediments and hardened into rock. So who has a dilemma? To find out, let's explore a specific case of fossilized dinosaur footprints discovered in Israel. So here's one corroborating the one in the Paluxy River in Texas. Here's one in Israel. Pertinent example. Just west of Jerusalem is the village of Beit Site. There, on an exposed rock pavement, a left foot, right foot sequence of fossilized footprints is clearly evident. In a closer view, the imprints of 3 long toes are plainly visible. Perhaps the most interesting clue about the formation of these footprints is the type of rock in which they are found. It is a unique type of carbonate rock similar to limestone called Dolomite. We see various types of limestone forming today, but Dolomite requires unique conditions to form, as determined in the laboratory. Dolomite forms today only in small quantities and only in extreme environments where dinosaurs could not possibly have lived, such as hot springs and desert salt flats. All other theoretical environments where dolomite might form are likewise not places where dinosaurs could live, such as hyper-salty lakes and oceans with unusual chemistry. So conventional geologists, who believe that the present is the key to the past, would not expect to find dinosaur prints in dolomite. The best explanation they can suggest is that, for some reason, a dinosaur walked across an intertidal mudflat in an arid region where there was nothing for him to eat. The problem is complicated by the vast scale of the rock deposits. The dinosaur prints are found in the lower section of a thick sequence of alternating layers of dolomite and limestone, half a mile thick, 2,600 feet or 800 meters, collectively called the Judea Group. Jerusalem sits on the Judea Group, which includes Mount Zion and the Temple Mount, Mount Moriah. A group in geology is not based on rocks in a relatively small area, but a pile of rocks identifiable over a very large region. Since it is a group, we must conclude that these thick limestones and dolomites in Israel were formed over a vast region. The only known way to produce large quantities of limestone, such as we find in the Judea Group, is in an ocean environment. The easiest way to form a widespread dolomite The easiest way to form widespread dolomites, too, is an ocean, but the water must have unusual chemistry. Must be of unusual chemistry. So the Judea Group probably formed in a vast ocean sitting over the entire region. This wasn't an optimum place for dinosaurs to live. Conventional wisdom. So how did the dinosaurs make these footprints under the ocean? Everyone agrees that the dinosaurs were land dwellers. So the conventional geologists cannot explain why they were walking across an ocean floor. Furthermore, even if the dinosaurs somehow left footprints in soft dolomite, mud, on a shallow ocean floor, how would the water-saturated sediment harden to fossilize the footprints? This can be done in only two ways: by exposing the sediment to the air so that the water evaporates from the mud, or by burying the mud so that the overlying sediment squeeze the water out of the mud. Explaining the Dolomite layers. How did flood geologists overcome all these challenges? First, let's explain the unusual chemical conditions. The pre-flood ocean floor would have been littered with the remains of mollusk shells in the form of lime. Mollusk shells are made out of calcium carbonate, the main ingredient in lime. When the fountains of the Great Deep broke up at the start of the flood, massive earthquakes would have caused the ocean waters to rise and sweep in across the pre-flood supercontinent like tsunamis, carrying the lime sediments landwards with them. The water temperature would have progressively increased as hot volcanic waters were added to the ocean. Also, many volcanic eruptions would have added magnesium to the lime-rich flood waters. Hey, we're getting a chemistry mix here. This combination of hot water, lime, and magnesium would produce the layers of dolomite. There you go. Thus, catastrophic plate tectonics can explain the increase in floodwater temperatures, the inundation of the continents, and the formation of enormous amounts of marine carbonate sediments on the continents. So, explaining the dinosaur footprints. As the floodwaters swept inland, dinosaurs would have been forced to swim to survive the rising floodwaters. Elephants today react similarly when faced with rising floodwaters. The water level at each location would not have risen at a constant rate. As global sea levels rose, water would rise and fall locally with a surge and ebb of tsunamis and the shifting tidal pull of the moon and the sun. At the same time, earthquakes and continual continental collisions would raise and lower land at different places and times. Consequently, warm, surging waters of the catastrophic flood might cover a particular lowland area with dolomite layers, only to expose that same area again for a few hours. This cycle could occur several times before the flood finally covered the area completely. Some dinosaur prints may have been made by fully submerged dinosaurs, others in shallow water, and others on temporarily exposed surfaces. Any brief exposure would probably not provide enough time, however, for the soft dolomite layer, composed of a natural quickset cement, to harden sufficiently to preserve the footprints. Instead, the next surge of dolomite sediment would bury the footprints, even if still underwater, and the weight of the overlying layers would squeeze the water out of the dolomite and harden it to rock. There you go. So the dinosaurs that made the footprints would again be swept away in the flood waters. Within weeks or months, they would succumb to exhaustion and die, to be buried in flood sediments higher up in the sequence. This explanation fits what is found in the geologic record. Dinosaur body fossils are invariably found in sediment layers higher in local strata sequences than their fossilized footprints. God's word solves the dilemma. So flood geologists have a satisfying explanation for fossilized dinosaur footprints in dolomite layers. But conventional geologists who insist on slow and gradual geologic processes struggle to explain both the dolomite layers and the preservation of the dinosaur footprints. When we base our understanding of Earth history on God's Word, we can explain fossilized dinosaur footprints, even in supposed marine dolomite layers. The truth is much more exciting than man's made-up history. Yeah, when you uncover all these things. Now, that's amazing. Well, let's get back to where we were. So there's that study. Now we have the in the Paluxy River in Texas, Glen Rose, Texas. We can look at those too. In any case, let's move on. Oh, okay, let's move on here. There you go. Notice the statement by Russell Tuttle, who is a professor of anthropology at the University of Chicago and with a primate research center at Emory University. He says, the third individual, G3, carefully walked in the footprints of the second. He points out that the GWI hunters of southern Africa follow up in the footprints of the person ahead in order to minimize noise and to protect their feet, and says overprinting would be a prudent habit. What are we looking at here? Oh, Mary Leakey in Africa, right. So, footprints. R.H. Tuttle, Professor of Anthropology, University of Chicago, primate research. So, oops. And so this is documented to be not that unusual of a feature. In fact, when we notice animals walking along, cows following each other, they step in each other's tracks. When we looked at the entire sequence of tracks beginning down at the bottom, we see a right, a left, a right, a left, a right, a left, and a right, and so on up the trail. They are consistent. The rights are where they're supposed to be. The lefts are where they're supposed to be. In each of the 14 tracks, we find at least a general human shape. Those shapes are very consistent in length. 7 of them reveal individual toes. Now, none of Mary Leakey's showed the individual toes apart from the big toe. In 12 of them, we can discern right from left. The right-left pattern is consistent all the way, every one of them, all 14 of them from one end to the other. Points towards natural occurrence instead of somebody counterfeiting them. And each of them is where it ought to be. And in the 110 million year old Glen Rose limestone, of the same platform with literally hundreds of dinosaur tracks stepping in and across them, according to the evolutionary scenario, it couldn't be there. Well, Dawkins tells us the significance of that. It would totally falsify the modern theory of evolution. Richard Dawkins, Oxford, The Blind Watchmaker. Evidence points unmistakably to the fact that the evolutionary scenario will not fit with the facts. Furthermore, there is a great deal of additional evidence discovered at Glen Rose that is accumulating. The Burdick track, for example, that had been cut out of the river back in the late 30s and early 40s. It is beautiful, almost perfect, human-looking footprint. Since this had been cut out of the riverbed, we were able to section this and saw it across it at the heel. And then we were able to look under the surface of the track. We can see the surface. And then under the surface, we see the disturbed area that conforms to the shape of the track, showing that this was not a carved track. This area of disturbed material of the rock directly under and conforming to the shape of the track proves beyond any shadow of a doubt that this track was not carved. We then saw the sort across the toes. We see that there are actually pressure indications under each of the toes, especially under the great toe. There are obvious indications of pressure which follow the contour of that big toe to that rock, proving that this was not a carved track, that it was an actual track in the sediment. Some diehards continue to object, saying, well, the track is just too wide to be a human track. Dr. Tuttle at the University of Chicago and also the Primate Research Center at Emory responded to the charge that Mary Leakey's tracks were too wide by using the illustration in his article in Natural History. His foot is seen on the left. On the right, we see an Indian's foot that habitually goes barefoot. He points out that this habitually barefoot foot is much wider than his. A wide width-to-length comparison to this Indian's foot found that it was approximately 48% width to length. We were able to look at the Burdick track and measure precisely and found that the width-to-length ratio was 48%. And so the illustration that Tuttle had chosen to refute the charge of too wide regarding Mary Leakey's tracks likewise refuted that kind of an argument with the tracks that we found at Glen Rose. R.H. Tuttle, Professor of Anthropology, University of Chicago. It's all in the details. So the layer that the Burdick track came from was found in Falls Branch, which is a tributary of the Paluxy River.